So 5.2, solving quadratic equations. We're going to do this by factoring. On your quiz, I'm actually going to be very specific. I want to see if you know how to solve by factoring. All right. You have this first example in your guided notes, 3x squared minus 17x plus 10 equals 0. If you haven't done so already, see if you can factor this, and then we'll talk about solving. What x's or what numbers can be substituted for x to make this statement true? We'll solve it. So we figure out what multiplies to 30 because that's our leading coefficient and our constant terms product. What adds to be negative 17? We set up the problem. We have negative 2 and negative 15. I have them short because I'm going to put them over the leading coefficient. So put them over 3. If it reduces to a whole number, or my bad, if it reduces to an integer, you're fine and you leave it. But because the first case does not, we're going to take that denominator and put it as the leading coefficient. The second does turn into an integer, so I don't have to worry about bringing any bottom up. And we can kind of quickly just make sure that at this step, does it check out? If you took 3x times x in your head, it should check out to be 3x squared. If you took 3x times negative 5, so here's where solving comes into play. You may have done this in Algebra 1, I'm not sure, but when we solve by factoring, here's what it comes to. When you have something times something else. So like, let me do a little thought box. You don't have to write this down, but a little thought. How in the world can I take two things and get 0? That's the question. One of these have to be 0 in order for you to have a product of 0. Similarly, we have something times something else equaling 0. That means I have to figure out what would make this entire parenthesis 0 and what would make this entire parenthesis 0. The way we set it up is we do like mini equations. What if this parenthesis was the 0? What would x have to be if I wanted that expression to be the 0? So you got to solve it. So after solving it, 2/3 would have to be in here. If I took 3 times 2/3 and then subtracted 2, this parenthesis would be the 0. That's the goal. X minus 5. So what would make that 0? I may not even need an equation for that. What would make x minus 5 0? What would x have to be in order for that to be 0? You say 5. So sometimes we don't need an equation. We could just say 5. Now, I'm putting boxes around these, but I don't exactly know if they're solutions. Let me just talk to you about the definition of a solution. Solution to this means if you plugged either of these in, you would get a true statement. Let me just give you an example using 5. Let's say I plug in 5 and I test it out. What would be my goal here if I knew I was doing it right? Yeah, okay. We get negative 10 plus 10. We do get 0. So it just verifies that 5 is a solution. Only thing we have to do here is get everything on one side and set it equal to 0. The only way factoring works, the only way you can factor or find factors is if everything's on one side and it's equal to 0. So getting like terms together by subtracting that 3t. So get rid of these guys. Subtract 3t, add 5. So we can do multiply add method. Oh, wait a second. Ooh, hold on a second. There's something special about this. I'm going to factor 2, leaving me with the rest. Greatest common factor. And then I can do multiply add with the stuff on the inside. What multiplies to, well, now my leading coefficient on the inside is just a 1. So now that I've gotten rid of my greatest common factor, my leading coefficient in this little guy is a 1. So 1 times 25, what multiplies to 25 and adds to give you negative 10. So now I have 3 things that are factors. I have 3 factors in this situation. So if you multiply 3 numbers by each other and you end up getting 0, that means one of those factors have to be 0. Well, hold on, wait a second. In this case, this factor cannot be the 0. So I just go on to the parentheses. So 2 cannot be the 0 because 2 is a 2. T minus 5. What does t have to be here in order for that to be a 0? This is a case where we only have one solution. Now, on the next slide, we're going to figure out why is this important? Why would we solve for this stuff? Why have it equal to 0? There is a purpose for this, and it deals with the graph of a parabola. Everything goes back to graphing parabolas. All right. This is why it's important to solve by factoring. First off, most of you know how to factor already, so that's why we like it. We don't want to learn something new. But this is why it's important. Find the zeros of y. I want to go through that last slide real fast, because you already have this written down on your guided notes. Zeros of a function are the same as x-intercepts to its graph. Zeros of a function are the same as x-intercepts of the graph. Synonyms of each other, zeros, x-intercepts, roots, whatever you have as your college algebra book, or whatever you have even in your trig pre-calc book, whatever it says. If it says roots, if it says the word zeros, if it says x-intercepts, they're all the same thing. That means their y-coordinate is 0. Wait a second, let me say that again. That means their y-coordinate is 0. It gives you a point on your graph. Your y-coordinate is 0. So going back to this, if I need to find the zeros of this equation, that means the y-coordinate needs to be 0 because it's an x-intercept. Let's start this out. So maybe make a little star, just so you know. We're finding x-intercepts. That means we're going to have the y-coordinate be 0. So let's put 0 in the place of the y-coordinate. And something that was in standard form, notice how this equation was in standard form. I can easily find the x-intercepts by factoring, because it's a method I already know how to do. It's a method I already know how to do. Let's factor. What multiplies to negative 6 adds and gives you negative 1. In that bottoms up method, you put your numbers over the leading coefficient, but in this case it's 1. So they're both going to become integers. To find my x-intercepts or my zeros, I'm going to try to figure out, okay, I've got a product here that gives me 0. So what would make this parenthesis the 0? And what would make this parenthesis the 0? So we get positive 3 and negative 2. So those are my zeros. It says find the zeros. Find the x-intercepts. It's at 3 and negative 2. So I could either write my answer as this, or I could write my answer as this. Or I could box these. Those also indicate it. But where we're going to take it at Chapter 5 test is realizing, hey, wait a second, that means this guy is crossing the x-axis at 3 and negative 2. I can immediately find my axis of symmetry. I can find my vertex using that, and so on. Part of Algebra 2 is realizing how can I manipulate equations or expressions to find different things. We just took something in standard form and put it in intercept form, and we found the x-intercepts. All right, you ready for homework?